Welcome to part 1 of lesson 1 of the topic Motors and Generators, where we'll introduce electromagnetism. Electromagnetism is one of the 4 fundamental forces that exist in our universe. There are 4 fundamental equations of electromagnetism, known as Maxwell's equations, which describe how charges produce electric and magnetic fields. There are also 2 force laws which describe how electric and magnetic fields exert forces on charges. Maxwell's equations are generally considered to be very beautiful when expressed mathematically. You can find them on t-shirts, mugs, wall hangings, and even as tattoos. In the HSC topic Motors and Generators, the focus of the syllabus rests heavily on the application of electromagnetism to motors, generators, and transformers, and their historical development and impact on society. There is, however, a fair degree of physical understanding required by the topic, and my approach here is to develop the physical understanding of electromagnetism first, and then cover the engineering, historical, and social science material required by the syllabus after that. To begin, I'll give you my shortest summary of electromagnetism. The fact that electric charges produce electric fields, and that electric fields exert forces on electric charges, may already be familiar from your Year 11 work. In the preliminary course, you also briefly covered the fact that a current-carrying wire produces a magnetic field. The remainder is likely to be new to you. The first thing to note is that there is a deep underlying symmetry. Electric fields are produced by charges, and electric fields exert forces on charges. Magnetic fields are produced by moving charges, and only exert a force on moving charges. The second thing to note is that there is a deep relationship between magnetic effects and electric effects. A changing magnetic field produces an electric field, and a changing electric field produces a magnetic field. In the next topic, we will see that this relationship gives rise to electromagnetic radiation. Here is a slightly more sophisticated qualitative summary of Maxwell's equations, which is matched 1-for-1 with each of the 4 equations, and which highlights the type of field produced in different situations. Firstly, there are 2 properties a field can have. The first, divergence, is a measure of whether the field appears or disappears at a point in space. An electric field displays divergence wherever there is a net positive or negative charge. In this case, electric field lines appear on positive charges and disappear on negative charges. The second Maxwell's equation says that it is not possible to make a divergent magnetic field because, as far as experimental physicists can tell, our universe does not contain isolated magnetic charges. The other aspect that can be present in a field is circulation, also known as curl. A magnetic field with circulation, that is, that points in a circle, is made by moving charges, or if an electric field at that point in space is changing with time. An electric field with circulation is made whenever the magnetic field at that point in space is changing with time. We will return to these summaries during the course of the topic. Here are Maxwell's equations, just because they are beautiful. My summary on the previous slide deals with them each in order. The first 2 relate to the production of electric and magnetic fields with divergence, and the second 2 relate to the production of electric and magnetic fields with curl. The physics syllabus has split the treatment of electromagnetism between the current topic and the next topic, ideas to implementation. We will therefore first treat the production of magnetic fields by moving charges, and the force that magnetic fields exert on moving charges, and address the remainder of Maxwell's equations in the following topic.